Hello, friends. Welcome to the online lecture series of the subject Digital Communication. Myself, Assistant Professor Mr. V.R. Wadekar, Department of Electronics and Telecommunication Engineering from Matoshi College of Engineering and Research Center, Nasik. Today, we will start the discussion with the outline of the subject. This subject, basically, it is for third year engineering students. It has total 5 credits. Theory, it has 3 credit points, and practical exam, it has 2 credit points. The examination scheme of this subject is in SEM of 30 marks of first 3 units, and end SEM exam, it is of 70 marks, so total it is of 100 marks. Now, in your first year of engineering, you had the subject that is basic electronics. In basic electronics, you have studied the unit called communication system. You came to know that communication system basically it is classified as analog communication system and digital communication system. In second year of engineering, you studied the analog communication in which you studied the what are the various different blocks used in analog communication. What is modulation? What are the types of analog modulation? And what are the techniques of it. As you know, there are various shortcomings of this analog communications, like noise, which is going to affect the signal very badly. Once this noise is introduced in the signal, it is very, very difficult to separate out the noise from the signal. So we couldn't use a repeaters over there. Even channel coding it is also not possible in order to detect and correct the errors. It is also not suitable for the transmission of secret information. So all these shortcomings are overcome by digital communication system. Nowadays, due to fast growing technology in the field of industries, defense sector, education systems, radio, television systems are all moving towards digital. So it is utmost to introduce and study digital communication system. So what are the objectives of this digital communication system? First, the objective of digital communication system is what we expect from the student is to understand the basic building blocks of digital communication system, to prepare mathematical background for communication signal analysis, to understand and analyze the signal flow in digital communication system. Next, to analyze error performance of digital communication system in presence of noise and other interferences, to understand concept of spread spectrum communication systems. Now, what are the outcomes once the completion of this course the student would be able to understand working of waveform coding techniques and analyze their performances. Then analyze the performance of a baseband and passband digital communication system in terms of error rate and spectral efficiency. Perform the time and frequency domain analysis of the signals in digital communication system. Next, design of digital communication system and understand working of spread spectrum communication system and analyze its performance. Basically, this course is divided into 6 units. The first unit is called Digital Transmission of Analog Signals. So basically, in this unit, we are going to see the introduction to digital communication system, what are the various blocks involved in it, what is sampling, quantization, what are the different modulation techniques, what is pulse code modulation, delta modulation, adaptive data modulation, and so on. The next unit is a baseband digital transmission. Basically, in this unit, we are going to see if more than two sources are there that want to transmit the information simultaneously, then how multiplexing it is going to help us in that scenario. What are the different data formats? What is enter symbol, interference, equalization, etc. The third unit is random signal and noise. Now, in random signal and in noise, once the signal it is transmitted, there is a chances of degrading the quality of the signal by random signal and noise. So what are the different types of noise are there? What is random process and how the transmission of random process through LTI filter it is going to take place, etc. The next unit, that is fourth unit, it is baseband receiver. In fourth unit, that is in baseband receiver, we are going to study the detection of binary signals in presence of noise. What are the types of filters? What are the probabilities error of it? The next unit, that is of fifth unit, it is called a passband digital transmission. In this unit, we are going to study the passband transmission model, binary phase shift keying, binary frequency shift keying, quadrature phase shift keying, and what are the error probabilities. And the last unit, that is called a spread spectrum modulation. In this unit, we will come to know about what is spread spectrum and why we are converting this narrow band spectrum into a wide band spectrum, what are the types of spread spectrum, and how we are doing it. Now, we would have a look on the references that we are going to use it. These are the references. Basically, the highlighted one, that is Bernard Sklar, Digital Communication Fundamentals and Applications, Dr. Sanjay Sharma, Communication System. These two books are important for unit number 1 and unit number 2. For unit number 3, Simon Haykin and K.S. Shanmugam. These are the books that we can refer. And most of the content, it is present, all units, it is basically present in your Bernard Sklar as well as Dr. Sanjay Sharma's Communication System. And I want to tell you that in the book of Dr. Sanjay Sharma, the language it is quite simpler that students can easily understand it. Now, moving towards the practical exam. So basically, you have a signal processing and communication lab. It has a credit too. And examination scheme, it has a practical of 50 marks and term work, it is of 50 marks. Now, first two practicals, that is of PCM, DM, ADM, they are from unit number 1. Third, it is from unit number 2. Fourth and fifth practical, that is of BPSK, BFSK, and QPSK, it is from unit number 5th. Now, this sixth, seventh practical, they are from unit number 3. And the last two practicals, that is of PN sequence generation, detection of DSS coherent BPSK, they are from unit number 6. So out of this one, basically, you have a 9 experiments and you have to perform a 6 experiments from group A that you have to perform it, and from group B you have to do any three practicals, and these three practicals basically it is of simulation. So either you can use a simulink over there or either you can use a MATLAB over there. Now, unit number 1, as I already told that unit number 1, it is a digital transmission of analog signal. As you can see the screen on the screen, that what are the various contents of it. Now for unit number 1, these two books are very much important. Most of the content it is going to present in these two books, so you can refer Dr. Sanjay Sharma's A Communication System and Bernard Sklar. Now, moving to the objectives of unit number 1, as we have seen the objectives of the entire course. Now, what are the objectives of unit number one? So, basically, from unit one, students are expected to be able to define and classify the communication system, to know the advantage of digital communication over analog communication system. Next, to understand and interpret the sampling theorem and what are the effects of downsampling. Next, understanding the basic building blocks involved in digital communication system. Now, what are the outcomes of unit number one? After completion of unit number one, student will be able to understand what is the importance of sampling theorem, understand what are the different sampling techniques are there. Next, what is the role of quantization and its types? And last is understand the working of waveform coding techniques and their performances. Now, moving towards the important topics of today's lecture. That is, first topic is introduction to communication system and its types. In primitive days, when human being they are used to live in small groups distributed over a relatively small geographical area, the communication system within the group takes place, you know, through speech, through gestures, through symbols like this. You can see on the screen. So as this groups is become larger, the civilization it is spread over a large geographical area. It was necessary to develop the methods of long distance communications, which includes such things like smoke signal it is there, then carrier pigeons are there, letters are transported by means of various means. Now, with beginning of this industrial revolution, as the technology is advanced, there is a need for fast and accurate methods for long distance communications. It become more important. The communication system employing electrical signals to convey information from one place to another. Nowadays, significant development it is going to take place in radar communication and microwave system. Next, in this laptops, in your mobile phones, then your defense sector, your lasers, then your satellite communications. So, this vast growth in this automation and computer industries, which made it necessary for computers and other machines to communicate not only with the people but also with other machines. So, in many cases, the information needs to be exchanged between people and machine or between machines is digital or numerical in contrast to the analog information. So, irrespective of the nature of this communication system, irrespective of the nature of the information being transmitted, we are going to use a generalized model for this communication system. First is your input signal. After this, input signal basically it could be in the form of your speech, it could be in the textual form, it could be in analog or digital form, or it could be in non-electrical form also. So basically, if input signal it is in electrical form, we can apply directly to the transmitter. But if input signal it is not in the form of electrical signal, we need to convert it into electrical signal by means of transducers. The next block it is going to come is your communication channel. So once input signal it is given to transmitter, the transmitter is going to transmit it. It is going to connect your information source with your communication channel. Now, one, the communications channel that could be wired or that could be wireless. So, when the information is being transmitted through this channel, it is received by the receiver, and from the receiver, it is given to the destination. So up till now, we have seen this generalized communication block diagram. So as you know, that noise, it is one of the important factor, that is one of the important factor that we have to deal with it in communication system. Now, so moving to the actual definition, what is communication system? Communication system is to transmit information bearing signals from a source located at one location to a user destination located at another distance location. Communication system may be broadly divided into two major systems. They are analog communication system and it is second is digital communication system. Now, in analog communication system, the information signal is continuously varying in both amplitude and time. It is used directly to modify some characteristic of high frequency sinusoidal carrier wave such as amplitude, phase, or frequency. What are the examples of it? Speed signal, video signal, temperature signal, pressure signal, etc. are the example of analog communication system. Now moving towards digital communication system. Now, in digital communication system, the information signal is processed such that it can be represented by a sequence of binary digits. If the input message is in the form of analog form, then it is converted into a digital form by the process of sampling, quantizing, and encoding. Computer data, telegraph signals are the examples of digital signals. Now, the question is why digital? Now, why digital? Because the transmission of information, that is of voice, video, data, over a path, channel, it consists of a wires, that is a wired, or it could be a wireless. So during propagation, what is going to happen? The amplitude and the shape of the sine wave, it gets degraded. As you can see in this figure, that this is a ideal binary digital pulse propagating along this transmission line, and the shape of this waveform is affected by two mechanisms. First is due to some non-ideal frequency transfer function of all transmission lines and circuits, and second it is unwanted electrical noise or other interferences which is further distort this pulse waveform, and both these mechanisms cause the pulse shape to degrade as a function of line length. So you can see from this figure that at a distance 1, this was the original pulse, and we have to send this pulse waveform to a destination 5. But as you can see that after reaching distance 2, there is some distortion it has been taken place into that pulse. As this pulse it is going to transmitted through distance 3, it is more degraded, and at distance 4 it is badly degraded. So what is going to be happen if during propagation, before the pulse is degraded to an ambiguous state that we couldn't recognize it, some corrective signal processing methods have to be done, and this process is called regeneration. In regeneration, the pulse is regenerated to recover its original ideal shape, and the circuit that is going to perform this function at regular interval along a transmission system are called regenerative repeaters. So hope so you got the answer that why digital. Now the next is moving to the next point, that what are the advantages and disadvantages of digital communication system over analog communication system. First, the use of regenerative repeaters, it generate a strong error free signal at a good power level. Digital circuits are less subject to distortion and interference than analog circuits. With digital techniques, extremely low error rates producing high signal fidelity are possible through error detection and error correction. Digital circuits are more reliable and can be produced at a lower cost than analog circuits. Digital hardware lends itself to more flexible implementation than analog circuits. And the combining of digital signals using time division multiplexing, it is simpler than combining of analog signals using frequency division multiplexing. Next advantage, it is different types of digital signals like data, telephone, television. It can be treated as identical signals in transmission and switching a bit by bit. Next, it is digital techniques lend themselves naturally to signal processing functions. Next, that protect against interference and jamming, that provide encryption and privacy. Storage and retrieval of voice, data, or video at intermediate point in the transmission is easy and is inexpensive in terms of storage space. Now, moving towards the disadvantages of digital communication over analog communication system. Digital systems tend to be very signal processing intensive compared with analog system. Digital system need to allocate a significant share of their resources to the task of synchronization at various levels, and some non-graceful degradation occurs in digital communication system. That is, when the signal to noise ratio drops below a certain threshold, the quality of a service it suddenly go from very good to very poor. The next point is digital communication system generally need more bandwidth than analog communication system, and digital components are consume much more power as compared to your analog components. Now, moving towards the block diagram of digital communication system. Now, in digital communication system, the first block is called source and input transducer. Source and input transducer, basically what it does, the source is where the information is to be transmitted, it originates, and the information may be available in the digital form. If they are already available in digital form, these data it can be directly modulated. But if the information available in non-electrical signals, then they it need to be converted into a suitable electrical signal using input transducer. Now, after this block, source and input transducer, the next block it is called a source encoder. Now, what does this source encoder it does? Basically, the analog electrical signal is sampled and digitized using an A to D, that is analog to digital converter, to make the final source output to be in digital form. So the process of efficiently converting the output of a source into a sequence of binary digits is called source encoding and data compression, because along with converting the data into a binary into a digital form, the source encoder it is also capable of doing data compression. The bits are then grouped to form a digital messages or messages symbols. Suppose if message symbols m equal to 2, it means there are two possibilities. It could be 0 or it could be 1. But suppose if symbols it is greater than 2, then there could be a chances of total 4 symbols. As like if two bits are there, it could be 0 0, it could be 0 1, 1 0, or 1 1 combination. Source encoder it is also going to remove the redundant or unneeded information. So if we are going to reduce the data redundancy, then source code it can reduce a system data rate, that is it reduce the bandwidth. And basically the source encoder it consists of sampler, quantizer, and encoder. Now after this source encoder, what is the next block? The next block it is called channel encoder. Now, what does this channel encoder it does? The channel encoder it introduces some redundancy in the binary information in a controlled manner so that the error caused by the noise during transmission it can be corrected at the receiver. This minimizes the effect of noise and interferences encountered in the transmission of signal through the channel. Hence, the channel coding it is going to increase the reliability of the received data and it improve the fidelity of the data. Now, what are the types of channel encoding? Basically, there are two types of channel encoding. That is forward error correction, uh, and next is ARQ, that is automatic repeat request. Again, block codes, cyclic codes. These are all the examples of your FAC. Now, what is the next block after this channel encoder? It is called a digital demodulator. As we all knew that what are the use of modulation? Basically, the primary purpose of modulation, digital modulator, is to map the binary information sequence into high frequency analog sinusoidal waveform carrier wave signal over a large distance. The examples of digital modulation it could be your amplitude shift king, frequency shift king, phase shift king, PCM, DM, ADM. You can see the waveform on the screens that if the data it is one it is there, you are going to observe the ASK modulated, then see for binary 1 the amplitude it is different, but as the bit 0 it is going to transmit, the amplitude is what reduced. Now again for bit 1 this amplitude it is going to increase and again amplitude it is going to decrease. This is for ASK. Now what about the FSK modulated signal? Now in FSK modulated signal you can see it is a frequency shift keying. It means what is going to change, it is a frequency. So for digital 1 bit 1 high frequency signal it is transmitted and for 0 low frequency it is going to transmit it. Next, it is called your PSK. That is a phase shift keying. In that, what is going to be happen? See, if there is a transition from 1 to 0, there is a phase shift. It is has been shown on the screen. And similarly, when the transmission transition it is going to take place from 0 to 1, again there is a phase shift it is going to take place at this place. Now, what is the next block of this digital modulator is channel as well as the noise. Now, the communication channel, it is a physical medium that is used to send the information from transmitter to receiver. And that channel, it could be wired, it could be wireless. And for wired, twisted pair, coaxial cable, fiber optic cables are there. And in wireless transmission, the channel, it is just maybe the atmosphere, it is a free space. Now, noise. The transmitted signal it is corrupted in a random manner by a variety of possible mechanisms such as additive thermal noise generated by electronic devices, man-made natural noise like automobile ignition noise and atmospheric noise, electrical lightning discharge during thunderstorms. Now, the next block after the channel is called a demodulator. Now, the demodulator basically it comes under a receiver section. So what the modulation does, demodulator it does the exactly the opposite to it. So it converts the input modulated signals into the sequence of binary bits. So digital modulation is defined as a recovery of waveform being transmitted. The next block after digit demodulator is what? Channel decoder. The channel decoder basically what it does, it attempts to reconstruct the original information sequence from the code used by the channel encoder and the redundancy contained in the received data. Now, what is the next block after the channel decoder? Of course, it is a source decoder. The source decoder it accepts the output sequence from the channel decoder and it converts bit back to the waveform. The next block it is called a destination and output transducer. So basically, Output transducer, if analog input signal it is in needed in non-electrical form, then output transducer it is going to convert the digital signal into the required analog input, and the destination it could be a computer, it could be a user, it could be data terminal equipment. Now what we have seen up till now, we can see this overall block diagram of communication system. So suppose you want to transmit a letter A, then source it is going to produce A. Then the source encoder, what it is going to do it by some algorithms, it is going to convert this A into what? A binary digits. As over here you can see that 011 010, it is the conversion. Now, after this one, what channel encoder does? As we know, the channel encoder it does the redundancy. Why redundancy? Because in order to detect and correct the errors while we have transmitted the informations, and this channel encoder, after adding this redundancy bits to your actual bit, it has been given to digital modulator. So digital modulator it is going to, it could be ASK, it could be FSK, it could be PSK. So over here you have been shown that FSK it has been used for binary 0. See the frequency it is low, but for binary 1 the frequency it is high. So this signal it is being transmitted through this channel, and again it is received by this demodulator. So demodulator, the output of demodulator, it has been given to channel decoder. Now the channel decoder, it is going to check. Suppose if there are even number of ones are there, it means the whatever the bit it has been received, it is correct. And suppose if there are odd number of ones are there, it means there is some error in that one. After this one, it is the output of channel decoder it is given to source decoder again it is going to convert back this one, it is going to give it to this destination. And if it is desired, the output transducer what is going to do it, it is going to convert back this transmission, that is digital bits, into its original message signal as like A. Now, the last point of this unit is a digital communication nomenclature. So, information source. Now, it is an analog or discrete information which is producing device used in digital communication. Next is called bit rate, the number of bits transmitted per second. The unit is bits per second, BPS. It is also called as data rate, and whose formula it is given by K upon T. Now, what is that K? K it is the number of bits in symbol, and T it is the duration of that K bits symbol. Next, it is what is symbol. It is a group of k bits considered as information unit. Suppose m is equal to 2 raised to k, and if k is equal to 2 bits, then 2 raised to 2, that is 4. So we got the four symbols, that is of 00, 01, 10, 11. And suppose k is equal to 3 bit, then 2 raised to 3, it means total different 8 symbols are possible: 000, 001, and so on. And last one, it is called a baud rate, or it is also called as symbol rate. So the rate at which the symbols are transmitted is known as baud rate. Now, in today's lecture, what we have seen, it is communication system. What is digital communication system? Why digital? We have seen the advantages and disadvantages of it. We have seen the each block of digital communication system. After that one, there is an assignment for you that you have to solve it. So you can see this assignment, and please you have to solve this assignment and you have to submit this one. So please note it down, this assignment. After this one, we are going to moving towards the end of this lecture. In next lecture, we are going to discuss sampling theorem. What are the sampling techniques are there? What is quantization, and what is pulse code modulation it is there. So for any questions, if you have any questions, if you have any query, or you want to post it some feedback, so you can post it to my mail which is given on this screen. So please you note it down. So guys, it is all about our today's lecture. Thank you very much, and we will meet in next lecture.